Good morning, Organic Chemistry 2. I am so excited to make this video. I've been having some issues saving and uploading my videos, and so I keep redoing them, and I'm hoping that this is fixed and this is a winner. Let's hope this is total Sparkle Pen. I hope this works. I am so excited. So we are a little bit behind. I'm going to post a couple of videos this morning. We're going to do some test review. And I'm writing your test today, and then in a day or two we're going to start Unit 4, and I'll have those videos coming up now that hopefully I've got things fixed on my videos. So let's try this. I put together just kind of 3 sample problems from some practice tests for this unit, and I thought instead of just posting an answer key, you've already got that I would actually go through and solve the problems for you. And I'm going to do a couple of these so that you can get maybe some ideas on how to study and how to approach some of this synthesis. That's what we had in mind that week after spring break, was to come back and actually just apply all those reactions we learned. So what I like to do in some of these problems is I started right off with the synthesis because they're my favorite. All right, so let's take a look at the question. And in this one, we're being restricted steps. Now, we haven't done that before. So let's just try the synthesis first, and then we're going to count our steps. We'll worry about that at the end. We'll kind of look at our strategy first, and then we'll look at it. And we're given a starting material, cyclohexanone. I'm just going to write that real quick so I've got an idea. Okay, done. I can already recognize that right here in our product. And then it says we can use any other reagents that you wish. Now, in our class, I tend to give a little qualifier. Hey, use some organic 2 reagents. Don't use organic 1. You shouldn't need it. Okay, so synthesis is all about strategy. What I like to do for synthesis before I do anything is really 2 things. I like to set myself up for success. I am going to literally number like crazy. And what I'm looking for in the numbering, I don't give a crap about naming. That's not what this is about. There is a strategy to numbering. I am going to use my functional groups, and I'm going to look for relationships. Now, we've had several relationships in lecture in this unit, and they're all based on spacing. They're based on that key spacing and how far apart some of our key functional groups are. So I'm going to number 6 ways to Sunday, and let's figure out if we've got some kind of functional groups that we've seen in lecture already. And then the second thing I'm going to do is I'm going to number everything like crazy. I'm looking for those functional groups. And then I'm going to try and practice. Sometimes synthesis can seem overwhelming, especially if your product looks quite intimidating. But if you could just try 1 step backwards, typically your life gets a whole lot easier. You can start to recognize things. Most of my synthesis problems, if you go 1 step backwards, you're going to recognize all the materials in there. And so I'm going to really try both of these things on some synthesis for you in a video, and maybe try to train your brain a little bit to do that. All right, let me erase this. All right, so let's set ourselves up for success. Let's try some numbering. We've got a nice ketone, which is part of this unit. We've got a nice amine. So I'm going to just number that way. I've got 2 functional groups. Their spacing is going to tell me what kind of reaction makes those things. Okay, so I'm going to just start right here and number. Immediately that 1, 2, 3 spacing has something we have seen in lecture all over the place. We have seen an aldol. We have seen a mannich. And they are all in that 1, 2, 3 spacing. So right away, even though the structure looks a little bit intimidating, just numbering those 2 functional groups, 1, 2, 3, already that's going to help me in 1 step backwards, isn't it? I can already recognize 1 and 3 right in my product right there. So this screams manic reaction. So if you use some of the strategies from lecture, remember we were really careful. We numbered all over the place in lecture. We numbered our aldols and our manics, and we made that connection that they're 3 apart. And for a problem that going backwards, that makes your life a lot easier. Okay, and then before we go one step backwards, let's look at what else is different in our product. We can set up our manic that way, but we don't have just cyclohexanone. We have some stuff over here also. So just for good measure, I'm going to count that spacing. Okay, let's erase for a second. How far away are we from our key component, number 2? So can I get there from an aldol? No. Nope, your aldol spacing is 1 and 3, not 1 and 2. Where did we see that 1, 2 spacing? Our enolates. So how are we going to make these bonds? We're going to use the enolate of that ketone. All right, so I like to do all of this before I even start to picture the answer in any synthesis. I like to set myself up to recognize some of the reactions that I've seen in class. Now, if I were taking your test, I'd have my cheat sheet right next to me. I'd have a whole section for aldol, whole section for enolates, whole section for manic, and let those mechanisms and what we did in class help you follow the rules for that reaction in synthesis. So let's pause for a second. Let's erase all this. And now let's try and use that system to go one step backwards. All right, so let's take that whole, we're going to number again, and let's see if we can just picture this compound one step backwards, and I'm going to write down just so that I have more space. One step backwards from a manic. Here's our 1, 2, 3. Now remember, our manic had 3 components to it. So if you've got your notes out, pause me, go grab your notes for a manic reaction. We had 3 components and we never wavered. Those 3 components are critical for the timing of the manic or it won't work. Step number 1, we needed an aldehyde, right? Step number 2, we needed a ketone. On step number 3, we needed an amine. So let's see if we can go 1, 2, 3, go backwards on that, figure out the bond we're making or bonds we're making, and let's try and identify what the aldehyde, ketone, or amine would be in this reaction. Now in our classic aldol, what bond did we make on the aldol portion? Always between 2 and 3. So we know we're making that bond. And then part of the manic, why it's so much fun, is that the manic is 2 reactions for the price of 1. Remember, the first step of a manic, you form an iminium ion. The second step of your manic, you do that aldol-like, let's put 1980s air quotes on there, reaction. Okay, so let's see if we can identify then what bond we're going to make for that iminium ion. We kind of have 2 choices, here or here, but really you need the iminium ion to contain that nitrogen, so it's got to be that one. All right, let's see if any of this helps us draw one step backwards. Okay, the first portion, that iminium ion, this is so exciting. That iminium ion is going to end up right here. How do we make an iminium ion? We need an aldehyde and an amine. Here's your amine. Here is your aldehyde. Go look at this unit. Look at the mechanism for that iminium ion formation. And what would our 2 starting materials be? We're breaking the bond right here on that green line. Ew, let's erase that. It's so cluttered, right? So how do we go one step backwards on that? Well, what's the amine portion? Our amine portion, I I think I need a blue pen. It's going to be this nitrogen. Okay. And didn't we usually start with that already a little bit acidic? So we could do that. Would I also take it as just the amine? Absolutely. I just want to recognize that that's the component from that. And what would be the aldehyde that's coming from? How about your benzaldehyde? Okay, awesome. So now, if we put these together, we're going to form that aminium ion. Now, just for funsies, why don't I draw that out so that you can recognize, hey, wait a second, that's where that chunk of that molecule is coming from. Okay. Awesome. So that would be our key intermediate. I'm going to put brackets on there. That would be our intermediate in the mannose. And then now let's do our aldol-like, where we use our ketone. Remember, this is all about rates. Aldehyde's going to react first. Ketone's going to be second. So we can use our ketone. We could use either this, wait for it, or already alkylated. Either one. And then what's the 1, 2, 3? Here we go. 1, 2, 3. And remember, these are sitting as enols. So that's where your 1, 2, 3 comes from. Okay, I love it. So hang on a second. Let's just scroll down. Holy crap. We just figured out one step of that synthesis and we just put together that whole thing. So let's scroll down for a second and just write out what we just did. We figured out that if we start with a version of this amine, whether it's protonated or not, I would be fine with benzaldehyde. And let's say we start with this ketone, done in one step. That makes our product. Holy crap. See what I mean by just moving backwards one step? Okay, now what we need to do is let's make this ketone. Okay, now we did exactly this ketone in your lecture notes. So if you want to grab your lecture notes for your enolate chemistry, I'm going to scroll down and I'm going to go one step backwards. Oh, I'm running out of space, y'all. I need a whole classroom board. Let's go one step backwards on here. And we need to add those methyl groups. Okay, how do we do that? This was straight out of our notes. We are going to use a base, and we're going to strategically use the right base in order to form that enolate. I am writing down sodium hydroxide. Why? Sodium hydroxide forms that most substituted or most stable enolate, and then I'm going to alkylate that just with a methyl. Okay, again, this one is exactly in your notes. So if we want to go one step backwards again, how do we make this one from our cyclohexanol? We can use any base to add that methyl. So we could literally do it twice. In fact, could we do that in the same reaction pot? We can. So this is awesome. If we were to pause for a second and draw this whole thing forward, we would find that this reaction we could do in actually only 2 steps. Start from your cyclohexanone, add sodium hydroxide and methyl bromide. You're just going to add it in excess. So let's add that to our synthesis down here. We would take our cyclohexanone. We would have sodium hydroxide. We would have methyl bromide. And we would put that in excess. And we would make that. So literally, this is sparkle pen. 1 step, 2 steps, and you have your product. Isn't that incredible? That is so much fun. All right, I want to make sure this video works, so I may be giving you a million small videos. I apologize for that, but I'm going to stop right now and make sure this one works and upload it, and then we'll come back and do another problem. I'll see you in a minute.